this question, we're dealing with two vectors, u and v, told various pieces of information about them, and we're asked to determine the size of the angle between the vectors u and v. So let's start with this statement here, which says that vector u dot u plus v. Now, when you're writing vectors, vectors are usually typed in bold font. It's very difficult to write in bold font, so you should be underlining them to show that they're vectors and not just normal number variables. So there's u dot u plus v, we're told, is equal to 21. Now, one of the properties of the dot product is that it behaves very much like multiplication of numbers and addition. So u dot, the sum of these two vectors, u and v, is going to be exactly the same as u dot u plus u dot v. And that's going to give us 21. Now, one of the definitions of the dot product of two vectors is the magnitude of the first one, the length of the first one, times the magnitude of the second one, times the cosine of the angle in between them. That's A and that's B. There's the angle in between them. And that angle ranges from 0 radians up to pi radians, or from 0 degrees up to 180 degrees. That's the range of angle measurement between two vectors. So let's look at this first one and see if we can use this definition here to make sense of u dot v. So it'll be the magnitude of u times the magnitude of u times the cosine of the angle between a vector and itself. That's a 0 angle, 0 radians or 0 degrees. So that's the first one. We'll come back to this. Second dot product here, magnitude of u times magnitude of v times cosine of theta, where theta is the angle between u and v. Let theta be the angle between u and v. Can't just suddenly introduce theta without saying what it is. So magnitude of u, magnitude of v, cos theta, product of these three numbers. And that comes to 21. Now, we are told the magnitude of u is 4. We know the cosine of 0. Recall the cosine values form the familiar cosine graph. Cosine of 0 is 1. Magnitude of u is 4. We're also told the magnitude of v is 5. And as yet we don't know the cosine of theta because we don't know theta. We're attempting to find theta. So this first term here, this first product is 16. 4 5s are 20. 16 plus 20 cos theta is equal to 21. Let's subtract 16 from both sides. And let's divide both sides by 20. We can cancel by 5 and we get the cosine of theta being a quarter, or 0.25. So we're now trying to find the angle whose cosine is 0.25. Now, either it's radians or degrees. Let's first of all find it in terms of radians. Now, in your calculator, it's likely to be cos to the minus 1 to find the angle, and mine it's a cos a. So we have to find an angle whose cosine is 0.25. And if we're measured in radians, if we're measuring in radians, there's the angle. So it's 1.318 and so on. So that's approximately 1.32. And that's to 3 significant figures. We can do that also in radians if cos, in degrees, if cos theta degrees is 0.25, that it implies, let's do the same calculation, what angle as a cosine of 0.25, but we're now in degree mode, and we get theta being 75.52. So approximately 75.5. And again, that's to 3 significant figures, or 1 decimal place in this case. So either of these 2 answers would give you marks for this question, full marks for this question. That's Mr. Corsi signing out. Hope you enjoyed the video.